This question is as follows. It's about a bubble of air which is breathed out by a deep sea diver. So first of all, write down the equation of an ideal gas. And the equation for the ideal gas is the following. So it's PV equals nRT, or PV equals nKT, where N is equal to the number of moles times Avogadro's number. So PV can be written as nKT, and nKT can be written as NA times KT. That's PV. But Na times K is another constant called Avogadro's constant, and it's R. So Na times K equals R, and this becomes nRT. Okay, so just in case you're asked to, you're not given R, and you need to find, say you're not given R and you're given N and K, then you'd use this equation. By making a suitable estimate, calculate the number of moles of air contained in the bubble, which has a volume of 20 at the surface of the sea. Assume the pressure inside the bubble is 1 times 10 to the power 15. So it says estimate, by making a suitable estimate, calculate the number of moles, okay, of air contained in the bubble. So if we use PV is equal to nRT, the assumption we're going to make is for the temperature, and for the, we've got the volume, we've got the pressure, we've got the volume, and we know that, so we're going to calculate N. So N basically, if you make N the subject, then have PV over RT, which is the pressure, which is 1 times 10 to the power 5, times the volume is given as 20. Now this is 20 cubic centimeters. So what we need to do is to change the cubic centimeters to cubic meters. Okay, so how do we do that? Just remember that 20 cubic centimeters is same as 20 centimeters times centimeter times centimeter. That gives you centimeter cubed. Now to change centimeters to meters, we divide by 100, divide that by 100, and divide that by 100. So basically it's 20 times 10 to the power 2, 4, 6, minus 6. So this is 20 times 10 to the power minus 6, divided by R is about 8.31, and T in Kelvin, that's the assumption you need to make. So bottom of the sea, you can take temperatures between 0 and 37, because maybe the bubble is close to the person. It's going to be maybe it's body temperature. So I'm going to take 20. If I take 20, that will be 273 plus 20, which is basically 293. Okay, so times 293. Now, do I have a calculator nearby? No, I've got to find the calculator. So where is the calculator? It's over here. And then I want this back. Let's have this back. So we've got some values to work with. Okay, so it's going to be 10 to the power 5 times 20 times 10 to the power minus 6 divided by 8.31 times 293, which is about 0.0008. So this is about 1, 2, 3, 1, 2, 3, 4. So it's 8.21 times 10 to the power minus 4. moles. It says calculate the number of moles. So that should be it. State what would happen to the volume of this bubble if the water were colder. Right, so if the water were colder, it means the volume is directly proportional to the temperature. So colder means a smaller volume. Okay, so smaller volume to shrink. Okay, so that's number one. I'll see you when I do number two.